All right, everyone. Today there's been more Gypsy Moth news going around. And I say Gypsy Moth, that's the old name. The new name for it is Spongy Moth. ESA decided to change the name for whatever reason, but Gypsy Moth is what you would look up for the last 200 years of literature. So that's usually what I call it because that's how I've always called it. Anyway, Scientific American put out this, I think, ridiculous story talking about millions of very hungry caterpillars are munching their way through U.S. forests, talking about how drought has caused this catastrophic, potentially record breaking outbreak of gypsy moth caterpillars throughout New York, Wisconsin, Michigan, um, and kind of the Midwestern area. And it just seems absolutely ridiculous to me. So, with this story, some background. So, the gypsy moth or the spongy moth was introduced in 1869 on purpose into, I believe it was Massachusetts, in order to hybridize them with silk moths to create a booming American silk industry. That was a totally failed project. The gypsy moths escaped and caused massive infestation. Since 1869, they've been spreading mostly uncontrolled and causing a lot of deforestation, especially in the first part or in the last part of the 1800s and the first part of the 1900s. There were lots and lots of infestations, defoliation events of forests, and the death of a lot of trees. In the early 1900s, the USDA and a bunch of universities began looking for biological control agents to contain the spread of gypsy moth to the eastern half of the United States, which did happen. The gypsy moths are predominantly in the northeastern quadrant of the United States, and there's been a century of work introducing biological control agents to kill these moths. They've been predators, parasitoids, which are usually wasps or flies. For those of you who don't know what they are, they're parasitic wasps or flies that generally feed on either eggs or caterpillars. And a number of pathogens have been introduced in order to curtail the spread and to limit the infestations. Despite all of that, the gypsy moth continues to spread, and there is a certain cyclical nature to the infestation boom and bust. So, generally speaking, populations will start low in an area and it kind of ratchets up year after year until you have this kind of catastrophic infestation, which defoliates a lot of forests, and then the population collapses, usually due to the presence of biological control factors. That, or at least that's how it's supposed to work. Ideally, what happens is that an area has enough predators and enough parasites and enough pathogens that you never get a massive population. You kind of curb an infestation. That will never happen because that doesn't even happen in their native range. In Europe and Asia, where the gypsy moth is native, they still have years where there's massive infestations because of this ratcheting effect, followed by a collapse in the population. So, Scientific America puts out this article very directly blaming drought. Basically, the dryness stresses the trees, it prevents the spread of fungal pathogens, which are both true statements about the nature of gypsy moth and its control. But there is a big problem with this, which is that we're not in a drought. This is the drought map for the United States, and the area that the gypsy moth would be present in, up here mostly, is not in drought, and it hasn't been in severe drought for a long time. So to blame drought is incredibly stupid. And even in the article they say, well, it doesn't need to be a severe drought. Then stop blaming the drought. It's annual summer dryness. That's not what's going on here. And the reason that they blame drought is because they want to blame this all on climate change, which is just another way for them to attract readers, I guess. But there is something that's going on here, which is, I think, much more interesting, but doesn't get people to read Scientific America because they can't talk about how, everything bad is climate change. There's actually an interesting biological series of events that causes infestation and will eventually destroy the infestation. That's much more complicated. So I wanted to talk about that here. So a little bit of explanation. So this is the drought map. Like I said, we're not in drought, and you can go back to previous years. We've actually had a pretty wet spring. the wettest spring since now has, I think it goes back to like 2019, which is when they said this, the drought in 2019 and 2020 kicked off this series of events, which again, there wasn't a severe drought in the area during that time. In fact, 2019 was extremely wet, and or at least in this area of the country was wet. The West is always just incredibly dry, but up in the northeast part quadrant of the country, it was fairly wet these years, and the gypsy moth population in these regions is actually, especially like Michigan, the state of Michigan just released an article about this a couple months ago, that the gypsy moth population has been in decline since 2021. So I don't know where they're getting off with this idea that this is somehow a record-breaking infestation. We haven't had a record-breaking infestation since the 80s, when all of the current biological control agents were introduced into the United States. Anyway, so if we look at some background information to explain what exactly is going on here. So this was a map put out for the 2021, and this is the gypsy moth infestation area. So the dark blue and this orange up in Canada, this orange-brown up in Canada, are quarantine areas for gypsy moth. They're definitely established. They definitely cause defoliation events. This sort of light blue on the border are monitoring areas and partial quarantine areas where we think gypsy moth is going into now, because it moves kind of slowly. It moves about 13 miles a year, although you can have humans accidentally moving egg masses long distances, which happens all the time, and states will then do localized extermination campaigns. So this sort of light blue on the periphery of these states is where the border is actively moving out, and you get active infestations into new areas, and then more monitoring in this sort of teal, where they're worried about it spreading. So the gypsy moth biological control agents for the last 100 years were primarily concentrated in the northeast of the United States. Some agents have since then, in the last 10, 15 years, been purposefully introduced across Canada into Michigan and Wisconsin, like Entomophaga myomyga is the fungus that's really important for this. But there's been a number of predatory species that have been introduced, a number of parasitic wasps or parasitoid wasps and flies that have been introduced, and other pathogens that have been introduced, particularly the nucleopolyhedrosis virus, which is a viral infection of Lymantria dispar, which is the gypsy moth, that causes the larvae, the caterpillars, to basically melt. And it is an extremely contagious virus that is predominantly responsible for the end of infestations. Basically what happens, and I'll show you a terrible drawing I did of this in a minute, is the gypsy moth is constantly moving out at 13 to 20 miles a year from the northeast to the west and to the southwest. This expansion is constantly increasing. As the moths move out, they are entering areas where moths haven't been previously, and they begin basically to take over because they have no natural enemies there. Maybe some birds, but they reproduce extremely fast. A female can lay hundreds and hundreds of eggs at a time. And so this area is kind of like, Garden of Eden for them. There's no predators, there's no disease, and they just eat and eat and eat, reproduce on this leading edge. And it causes massive infestation. Year after year, this gets bad. Eventually, on this leading edge, a diseased moth will show up, and Entomophaga myomyga, or this NPV, usually this nucleopolyhedrosis virus, NPV, shows up and wipes out the population through a massive, it's called an epizootic, but we would call it an epidemic in humans. The reason that this is happening is because there's no other natural enemies in this area, so it's very, very dependent on pathogens to do this work. So let me find this other image. It's a terrible drawing I did. I couldn't find the original image, but it's an image that explains the relationship between kind of predators and insects, parasitoids and insects, and pathogens and insects. So this is, on the x-axis here, this is the population of an invasive insect species. And it's really the population plus population density. So as the population of an invasive insect species increases in an area, what is killing those insects in the area if there are natural enemies present? Predators are really good in a sort of low to moderate population density of an invasive insect if you have predators available. They will kill a lot of caterpillars if you have like carabid beetles and things like that, or even birds and mice and things. They'll eat a lot of beetles. But the problem is this concept called predator satiation, which is at some point there are more insects than the predator can possibly eat, and they get full. And at some point, if the population of the insects are really high, the predators stop making any sort of dent in the population. This mouse or the bird or the insect can only eat so many caterpillars, and when there's millions or billions of caterpillars, they don't make a dent. This is when the parasitoids come in. Parasitoids, again, are like parasitic wasps and things like that. They generally lay their eggs inside the host body and then kind of consume them from the inside out. That's how you can think of it, kind of like the xenomorph from Aliens. Parasitoids can lay a lot of eggs inside of a lot of caterpillars. So they're really good in sort of like the middling population densities. When there's a lot of caterpillars around, they go crazy and they just lay eggs everywhere. But again, when you have really, really high populations of an insect, the parasitoids can only do so much work. And that's where the pathogens come in. Pathogenic control of a population is really terrible when there's not very many members of the population, or when they're really spread out far apart. Because the pathogen can't be transmitted from host to host to host in an efficient way. So like with the Entomophaga myimaga or the NPV virus, it only is really, really lethal when the population is really, really dense. So when you get a massive population of these insects, that's when the pathogens come in and just wipe everything out. The more insects, the better. And it spreads incredibly fast. And then the next year, suddenly there are no more moths in the area. So this is really good for controlling an infestation when it's really high, but if you want to prevent an infestation from occurring, you want to take action in these areas. You need parasitoids and predators. Going back to the original map that I was talking about, on this, remember, the biological control agents were mostly focused in this area on the East Coast, and the infestations, the worst of the infestations, are occurring here on the edge. The viruses and the fungi will eventually get to this edge when a sick insect arrives, or a lot of times spores are born on the wind, and they will wipe out the infestation when it occurs. But when it comes to suppression, again, you want those predators and parasitoids. The predators and parasitoids were all introduced over here, and they move very, very slowly. It takes several years for them to catch up with the moving edge of the infestation. So this moving edge of infestation will always have more damage because the moths are moving into an area where there are no predators or parasitoids, and the predators and parasitoids have to catch up with their prey. Eventually, they will, and you'll get more suppression in this area, but by the time that occurs, the infestation has moved a couple counties over again. So it's this cat and mouse game going on all the time. So you can't rely on a pathogen to prevent an infestation. You rely on the pathogens to destroy the infestation, and you rely on the predators and parasitoids to prevent the infestation. But yeah, this is just kind of hand-wringing, fear-mongering. Everything that's bad is because of climate change. This is a bad situation, but it will eventually take care of itself for the most part. There's been a lot of work done on this subject in order to prevent long-term damage. But again, this is a cyclical thing. Every 15 years, you'll have another outbreak of gypsy moths in an area. And at the end of that 15 years, the pathogen will come in and wipe out the population. So it's just round and round we go. This is never going to stop. But whenever it happens, there'll be more hand-wringing and end-of-the-world nonsense. But that's all I wanted to talk about today. Talk to you later.